Hello, my name is Maya. I'm a sophomore in the AI major, and we are group number 8, and we are going to present our final project for SIS 3500, which is our Google Chrome extension called ScholarSearch. As I mentioned, my name is Maya. I'm a sophomore in AI, and now my teammates will represent themselves as well.
I'm Layla. I'm a senior studying computer science and cognitive science.
Hello, I'm Andrew. I'm a sophomore studying AI and cognitive science.
And my name is Angelina. I am a junior studying computer science and music.
So the challenge that we decided to solve is researching academic papers is inefficient. Basically, as students and as professionals up there, we figured out that we spend a lot of time searching for specific academic scholars that we can use while writing papers, essays, and everything else that we need while finding data and information about basically everything. We saw that it is one, time consuming, and two, inefficient whenever it comes to filtering and finding papers that are actually relevant. We figured out that this is happening most of the time because the search bars only include keywords, which depend on the title of these articles, and most times does not actually give an in-depth, relevant article that is more about what the article is about. We came up with a really interesting and cool solution called ScholarSearch. Our Chrome extension basically streamlines this entire processing. It's AI powered, it ranks the score relevance based on each article's abstracts and not merely based on the title. And it has real integration with semantic scholars to get these papers.
So the features that we actually implemented to build ScholarSearch included one, dual input. So when you use our Chrome extension, you can search for papers not only using keywords, but also with a natural language research question. And this allows scholars to not only find the papers that address, keywords, but bigger questions and their deeper intent behind the search. Second of all, by integrating with the Semantic Scholar API, we're pulling from a really high quality database that's well maintained and includes a host of strong and reliable academic papers. Third of all, we use OpenAI's API to actually rank the papers that are returned to you by relevance. Usually, platforms have a relevance ranking system in place based on your keywords, but since we also incorporate this natural language feature, we can construct a prompt to OpenAI that allows it essentially to rank the papers that Semantic Scholar returns based on your intent. And lastly, having to do with the fact that ScholarSearch is a Chrome extension, one plus of our product is that it is browser native. So as you're researching, you can have this side panel to help you stay focused and efficient as you do your research.
So, in terms of the architecture and technical decisions that we made for the ScholarSearch Chrome extension, we had four major components in this pipeline. So, the first one was the Semantic Scholar API. So, the Semantic Scholar API is what really retrieves the curated list of academic papers based on the user's search query. So, that API provides access to metadata like titles, abstracts, and URLs, which would allow us to quickly gather the candidate papers. So, in order to optimize for the speed and API rate limits set by our API key, we had to limit the number of results and request only the most relevant fields, like the titles, abstracts, and URLs that we are providing back to the user in the search results. Next, we have the OpenAI API. So after retrieving the papers from the Semantic Scholar API, these abstracts would be fed into the OpenAI API, so GPT 3.5 Turbo, and then semantically ranked using that GPT 3.5 Turbo based on their relevance to the user's search query and their keywords. So this model would analyze the context of each abstract in context, assigning relevance scores that would guide the final order of presentation on the search results page so that the user gets back the papers in ranked order of relevance. So next we have Fast API and render. So Fast API was really used to tie together our backend logic with the front-end interface. So we would have fetching paper abstracts with Semantic Scholar and then ranking them with OpenAI, and also handling the user requests from the front end and then also displaying results on the front end. So we used Render to host this Fast API backend online so that the Chrome extension could access it without needing a local server. So together, the Fast API and Render allow the extension to send the query, process it remotely, and then show the ranked academic results to the user. And finally, we have Manifest v3, which ensures that our ScholarSearch extension meets the modern standards for Chrome extensions and also improves its performance and overall security. The updated architecture of Manifest v3 has support for efficient background processing and asynchronous communication, which would help our ScholarSearch extension to be fast, stable, and user-friendly within the Chrome extension interface.
Throughout the process of developing this Chrome extension, there are a few major challenges that we faced. The first challenge was the API rate limits. Since the APIs required us to subscribe to um, the OpenAI's paid plan and input credits in order to use it, um, we had to initially set that up and make sure that we had enough credits to APT to be able to enable the APIs to be integrated into the um, entire pipeline. And second of all, we also faced into some challenges of getting useful results from OpenAI. And so for that issue, we made sure to modify our prompts to make sure that we get the relevant rankings that we need in order to finally sort our papers and return them on the front end. Finally, the major challenge we encountered was integrating everything together because we had to make sure that the output from Semantic Scholar was fed into OpenAI and then finally fed to the output. And so that required piecing together multiple calls from separate files, and that was a little more complex than expected. Um, and some reflections we learned from the process include version control, making sure that we try to break down every commit into a clearly labeled feature in order that our teammates can keep track of what was changed and see what works and what doesn't work and modify appropriately. The second reflection is that we separated the logic for API and UI front end stuff, as well as the ranking logic into clear files to make collaboration easier, especially since we are a team of four and we're working on different parts that have relationships with each other. Finally, we made sure to prioritize the user experience to make sure that even if we're designing the MVP, we had to make sure that this was usable and user-friendly for users. And we had in mind how we could better prioritize the experience for users such that it is not merely a combination of searching on Google Scholar and asking ChatGPT, but in fact, it's an enhanced version that allows them to better customize their search for academic articles.
So now we have a UI demo to show you of our extension. Today I'm going to be showing you how to use our Chrome extension called ScholarSearch. So let's say you're researching a topic. It could be on any site in any workflow, but let's just use Google Scholar as an example. Typically, you type some keywords in the search bar here, but using our Chrome extension, ScholarSearch, you can open a side panel that will allow you to refine your research with both a research query as well as keywords. So let's say we wanted to answer the question, how is artificial intelligence inspired by neuroscience? Then you can add some keywords. So let's say artificial intelligence, neural networks, neuroscience, the brain. And you click Find Papers. So now it's accessing the Semantic Scholar API which is an API to a well-maintained and reliable database of academic papers that it's going to draw its results from. So finally here, you get your results. The results are ranked according to relevance to your keyword, as well as to your research query. Each result here is given a score according to the relevance to what you searched for. And then the abstract of each paper is summarized. You can view more or less, and the information presented to you here is unique from what you usually get in that most searches are done only on the titles of papers, but not on the abstracts. But using the Semantic Scholar API, we are able to query the abstracts of papers and present you a summary as well. So as you scroll through your results, you might be interested in one of them, and you can click to view the paper in a new tab. This side panel stays open so that you can compare the article you're looking at to other results. One last thing that we'll mention is that you can go back to the search from here, also find out more about how to use ScholarSearch by clicking the question mark. So thank you and happy researching. So that's our demo. And with that, thank you.